All right, so today we are going to talk about the ellipse. The ellipse is just another shape in the math world that gets used a lot in many different things. So typically we talk about these in what's called a conic section and regular trig. We're just going to only talk about two conics here in 127. We're going to talk about the ellipse today, and we're going to talk about the hyperbola next class. So an ellipse looks very similar to an oval. So it's a collection of all points in the plane as the sum of whose distances from two fixed points called the foci is a constant. So you're going to have a center. You have these 2 points that are called vertices. So vertices are in the same line as the center. So these are called vertices. They don't really talk about these in 127. I'm going to talk about them in this class though, because I talk about them in my regular trig. So these are called what's called covertices. They just help you draw the ellipse a little bit better. And then your foci are just right here. They're two fixed points that are equidistant from whatever you're looking at. Okay? So we have two different equations for an ellipse. You can either have what's called the major axis along the x-axis or the major axis along the y-axis. You can have ellipses at center 0, 0, or we're going to see later you can have ellipses without a center at 0, 0. So if we have a center at 0, 0, this is saying that the major axis is along the x-axis. So this is your major axis. It also means your vertices are on the x-axis. Okay? This equation looks like x squared over a squared plus b squared, plus y squared over b squared. And everything should always equal 1 when we're talking about ellipses. If they don't equal 1, you need to divide it out so that it does equal 1. Okay? This I don't really like to use. Instead, what I use is a modified version. So to find the foci, you're going to take c squared equals a squared minus b squared. And then that's what helps you find your foci. Okay? Vertices are always going to be the a values. Okay. So analyzing the equation of the ellipse. So x squared over 16 plus y squared over 8 equals 1. So this is the bigger number, which means that this is my a squared, this is my b squared. So to find the vertices are plus or minus a comma 0. So we're going to have to take the square root of 16, which is 4, and we get a positive 4, 0 and a negative 4, 0. So positive 4, 0 and a negative 4, 0. All right, to find the foci, we're going to say c squared equals a squared minus b squared. So c squared equals 16 minus 8. So c squared equals 8, which means that c equals 2 square root of 2, which is, it's plus or minus. So which is somewhere, obviously, in here. Okay? You don't have to do this, but I like to do this to help me figure out what my shape is going to look like. So I find what's called the covertices. In this case, it's 0 comma plus or minus b. So the square root of 8 is 2 root 2. So that means my covertices are 0 comma 2 root 2 and 0 comma negative 2 root 2. So that's somewhere in here, somewhere in here. It just, again, for me, it helps draw that ellipse a little bit better because I know how far I'm supposed to go up or down. This right here is considered the major axis, which I believe is what question D asks. It says, how do you determine which is the major axis? It's in line with the vertices, which were here and here. Remember, these are called covertices. Okay. So now the other way we can do this is if the major axis is along the y-axis. So again, something I need you to remember is A is always the bigger number. And it goes with the major axis. Remember, you can pause this video at any time or go back if you miss something. So my center is still going to be 0, 0 for now, but notice now my foci are on the y's, and my vertices are also on the y's. So my equation now is still x squared plus y squared, but now my a squared is going to be under the y squared because it's the bigger number. My foci is still c equals a squared minus b squared. Okay, so you can notice the difference here. My longer axis is along the y-axis. So for this example, we're analyzing the equation of the ellipse. Notice they do not give it to us in the right form. They give it to us where it equals 36. And we always need this to equal 1. So what we need to do is we need to take this equation and you divide everything by 36 because, again, you need this number to equal 1. So whatever I do here, I'm going to do here, and I'm going to do here. If you can't do this in your head, if you don't know that 9 goes into 36 4 times, so that's going to be 1/4, then you can by all means do it in a calculator. So we should get x squared over 4 plus y squared over 9 equals 1. So as you can see, there's my bigger number. It's underneath the y. So we know that this is going to be along the y-axis because the a value is under the y. Okay, so again, to find my vertices, it is 0, comma, plus or minus a. This time it's on the y value because that's where my major axis is. So I'm going to take the square root of 9, which is 3. So we have 0, 3, and 0, negative 3. So 0, 3, and 0, negative 3. I could quickly find my co-vertices. That is going to be now plus or minus b, comma, 0. So that's the square root of 4, which is 2. So this is going to be 2, 0, and negative 2, 0. Again, I do this to help me make my graph. To find my foci, I'm going to do c squared equals a squared minus b squared. So that is c squared equals 9 minus 4. So c equals the square root of 5. Which means that this point is 0, comma, root 5, 0, comma, negative root 5, because plus or minus. Root 5 is somewhere between 2 and 3, so somewhere in here and somewhere in here. Then again, like I said, I like those co-vertices because I feel like it helps me draw that a little nicer. And then again, here's my major axis. Okay, so then what we can do is we can shift these ellipses where the center now is not 0, 0. Notice it is HK form. We've been doing HK form for years and years and years at this point. You can see the new-ish equations for foci and vertices. Basically, it's the same as what we've been doing. So if it's if the major axis is along the x-axis, it's still plus or minus a, comma, something. It's just that now we have h plus or minus a, comma, k. So these equations are x minus h squared over a squared plus y minus k squared over b squared equals 1. This one is still x minus h squared, but now it's over b squared plus y minus k squared over a squared equals 1. So again, remember, a is always the larger value. So wherever A is at, that tells you what your value is. The other thing to notice is very similar to circles that we did in semester 1 in 126 is H and K are both opposite of what you think. This is something new. We're used to H's being opposite of what we think. We're not used to the K's being opposite of what you think. But because of that minus sign in the formula right here, it makes your K's also opposite of what you think. Okay? So again, all we're doing is taking that center and shifting it away from 0, 0. I only have one example here to do with you. It's kind of a hefty example because you also have to complete the square, but I wanted to make sure that you knew how to complete the square as well. And then I show you how to move everything around. Okay? So we're going to analyze this equation. I am going to change this number right here. I want you to change it to a plus 141. Okay? So the first thing we're going to do is rewrite this equation in standard form. So I'm going to group my X together and my Y together and move the 141 at the same time. So here are my X's, here are my Y's. So 25x squared plus 150x plus 4y squared plus 16y equals negative 141. Okay, my next step is I need 1 on x squared and y squared. So I'm going to need to factor out a greatest common factor. So here I factor out a 25, leaving me with x squared plus 6x. Here I'm going to factor out a 4, leaving me with y squared plus 4y. And I still have the negative 141. Now I'm going to need to complete the square on these two pieces. To complete the square, you're going to do b over 2 squared, and this is going to become the end value. So 25 times x squared plus 6x plus something, that's what we're trying to do. We're trying to complete the square, plus 4 times y squared plus 4y plus something. Well, whatever I do to one side, I have to do to the other. So on the left side, I'm taking that 25, and I'm going to times it by some number. And also on the left side, I'm taking that 4, and I'm going to times it by some number. If I'm adding a number to the left, I need to add that same number to the right to balance equations. For those of you in chem, you'll remember this. Whether you took chemistry here at the school, if you're in Chem 121, you'll remember this idea of balancing the equations. So I'm going to say b over 2 squared, so 6 over 2 squared, which is 3 squared, which is 9. Here I have 4 over 2 squared, which is 2 squared, which is 4. My next step essentially is to factor these, but they should factor into perfect squares. So they should factor if you've done it right into this number. So what multiplies to give you 9, that adds to give you 6, well, that's 3 and 3. What multiplies to give you 4, that adds to give you 4, that's 2 and 2. So then we can write this as 25 times x plus 3 squared plus 4 times y plus 2 squared. And this gives me, when I plug all of this into my calculator, as you get scientific calculators, I get 100. I need this to equal 1, so I'm going to divide everything by 100. And this is now my final equation I'm going to use to graph my ellipse. The first thing I notice is what type of equation is this? Well, you have to figure out where that a value is. That a value is always your bigger number. So this is going to be my a squared. It goes with the y, which means my major axis is going to be parallel to the y-axis because the a squared is under the y. So that means my center then is going to be 0, comma, plus or minus a. But we've shifted this. Oh, sorry. My center is going to be 0, comma, 0. But we've shifted this to h, comma, k, where both of these are opposite of what we think. So my center is going to be -3, comma, -2. So now my foci is typically 0, comma, plus or minus a, but we've shifted that, so you've got to take h, comma, k, plus or minus a. So first of all, my a is 25, so the square root of 25 is 5. So we're going to take this -3, comma, -2, and we're going to add 5 to it. And then we're going to take this -3, comma, -2, and we're going to subtract 5 from it. So, and this is my vertices. So sorry, this is D. So this is vertices. So this will be, okay. All right, so this becomes -3, comma, 3, and this becomes -3, comma, -7. So really quick for a minute, when I go down here to graph, first of all, my center is at -3, -2, and then my vertices are -3, 3, so -3, 3, and -3, 7. -7. So hopefully you can see that that's where that axis is going to go. Okay, then again, you don't have to do this. I like to do it to help me. So I'm going to find my co-vertices, which in this case would be plus or minus b, comma, 0. But again, we're dealing with the translation. So it's going to be h plus or minus b, comma, k. So it's going to be that -3, -2. B is the square root of 4, which is 2. So we're going to add 2 and we're going to subtract 2. So we get -1, -2, and -5, -2. So -1, -2, -5, -2. Hopefully you can see now how that helps you draw your ellipse a little bit better. Again, you don't have to do those co-vertices. I don't know that it's ever going to ask you like in your homework on a test, but I feel like it really helps you draw that ellipse a little bit better. All right, the last thing we have to do is find our foci. So our foci is still c squared equals a squared minus b squared. So c squared equals 25 minus 4. So c squared equals 21, which means c equals plus or minus the square root of 21. So normally this point is 0, comma, plus or minus c, but now it's got to be h, comma, k, plus or minus c. So it's going to be -3, comma, -2, plus or minus the square root of 21. Those are where your foci are. It does typically ask you to find your foci. We don't always graph them because a lot of times they're square roots, and so you get these funny looking numbers. However, you do have access to a scientific calculator, so you could plug that in to get those numbers. Square root of 21 is somewhere between square root of 16 and square root of 25, so somewhere between 4 and 5, but you're adding that -2, so somewhere between 2 and 3-ish, so you could figure that out. I would just use a calculator. So that kind of culminates everything from this unit, so you have to complete the square, or this chapter, you have to, chapter section, you have to complete the square, get your equation, all of that stuff. If you're still struggling with completing the square, what I suggest is maybe today going online and finding just some random completing the square assignments, so you can do that. You can also be doing it, you can grab a textbook from the back of the class and go to section 9.1, I believe, is the ellipses in the trig textbooks in class. And there's problems there with it. If you do the odds, there's answers in the back of the book that can help you complete the square. If you have any questions, make sure you come by and see me.